Okay, so when we started to work on this presentation, we realized that we're not able to really give specific customer use cases, just because we're so far into their deep dive into their product design process. So what we decided instead is we're going to show you the tools that people in your industry or sector are using in order to basically to train, wear, and populate Web 3D. So let's dive in. Oops. Okay, so there's lots of different ways to capture 3D. So what I wanted to do is show you, we're going to be showing a lot of image sequences, so I wanted to start by showing you how it's done with this technology. So basically, this is a short clip of our cranial system as far as capturing a full 3D image of the head. So we'll start here. This is the configuration. We've basically got 15 cameras, 5 viewpoints, and we're going to capture the subject.
3D only, advanced 4D frontier.
Okay, we captured him at 60 frames per second, and basically you have the ability to batch mode process all of the images, or you can select a specific image in order to render it. What you're going to see here is 3DMD's rendering image, where we are rendering the 3D image. And the importance of this is the accuracy of the shape information. It's not just really an avatar. The most important thing is the sub-millimeter accuracy of the geometry, and then we apply a texture on top. At this point, I just want to make it really clear that there's a lot of different technologies out there, and there's a lot of different applications for all of these technologies. But the reason why people would utilize this type of system is because they need near ground truth anatomical 3D information, shape information, along with the texture, but that is really why people are using it. So, okay, so we got started in 1999, 2000. So I always chuckle a little bit when we've been here 2 years now, and we're considered a startup on the AWE slide presentation. If so, we are a geriatric startup. We got started in computer vision community way back when, and at that time, basically the industries, sorry, I have to look down here. Okay, the industries that were utilizing 3D scanning, reverse engineering and manufacturing, which is real easy because they're working with static objects. They're not going to move. So when we started looking at, okay, how do we scanning people, the industries that we're talking about it were the standard film, gaming, biometrics and security, definitely after 9/11, the apparel industry as far as personalization, virtual dress, and healthcare. And at this point in 2000, documenting the patient in 3D for clinical application was the industry that was really keen on this. So that's where we pivoted and we focused at that time. To do so, what we did is we partnered with 2 world-class facial surgeons. One of them is Professor Schindel. At the time, he was the head of plastics in Stanford, and as well as Professor Peter Ward Booth, who was the head of plastics in East Grinstead in the UK, which is really it's the birthplace of plastic surgery, because that's where it started after World War II when the kids came back to the UK. So basically, from that standpoint, what they wanted us to do is they wanted us to look at imaging, creating a surface imaging modality that could capture children for craniofacial anomalies. Especially their interest was cleft lip and palate. So because they're children, one of the main objectives that we had to achieve was speed of capture, because I've imaged tons of people over the last 20 years. There is no one more difficult than a 2-year-old. So that got us off on the right start for people. So what we did is we focused on surface imaging for clinical application. And in order to be considered a medical modality, basically you have to have a one-to-one correspondence. So it can be, whether it's CT or MRI, they need to be able to be one-to-one, so the measurements on the surface image are the same as if you were to do it on the person. So here you can see we're combined with, I think that's cone beam CT, which is a lower radiation dose. And what they use this for is surgical planning and outcomes assessment. So that was where we got started. And what I want to do, I know we want to get to Chris's part on how this translates to the Web 3.0, but what I wanted to do was to show you kind of the foundation layer of what we had to do in order to get to where we are today. And quite honestly, we're in hospitals all around the world, so we're still there today. So I just wanted to start real quick. Royal Children's Hospital, basically they've been our customer for 20 years and they've really pushed us. So this young man has a craniofacial anomaly, Perry-Romberg's disease, where half of the face wastes away. So what the surgeon did is they did a symmetry assessment and then calculated the volume for the surgical plan. This one is a Pectus brace therapy. So you can see the chest deformity on the young man right there. At the time, before 3DMD was there, it was a combination of surgical intervention as well as Pectus brace therapy. And surgery, as we all know, is invasive and it can be traumatic. So the Pectus brace therapy was preferred. However, getting teenage boys to do what they're supposed to do and wear the brace was a huge challenge, especially because it was in Australia and it's a beach culture there. So what they did is they started imaging the patients, and they started imaging the patients and then quantifying and showing the patient, okay, this is where you were 2 months ago, this is where you are now, and the patient could see, oh my gosh, it's better. So it helped for the patients to actually wear the brace. So today, there's no surgical intervention done for this chest deformity. Basically, Pectus brace is all they use, so they were able to eliminate surgery, which is awesome. Same thing for cranial helmets. Before, they used to have to put plaster bandages on the head in order to get the mold, which is traumatic to a child. So what they did is the same thing. They imaged the patient, and then they were able to make a plaster mold in order to build the cranial helmet for conditions like plagiocephaly. But you can see here the first image at the start of the treatment cycle, and you can see the orange compared to the purple there, as far as the parents could see, okay, this therapy is working. And lastly, basically 3DMD has been in civilian military hospitals around the US for 20 years. For this project, though, the Navy and Air Force, what they were doing is they were imaging the military personnel before they deployed. They took a 3DMD image as well as a low radiation cone beam CT. So they all had that before they left. For this project, what they did is some of the warriors were wounded, so they were looking at ear replacement or ear reconstruction. So they took the images and they were able to fabricate and 3D print ears in order to help them through their rehabilitation. So with that, I'd like to introduce Chris Lane. He is our Chief Technology Officer as well as our CEO.
Thanks, Kelly. So if there's any, I'm not supposed to say this, I don't think, in the modern world. We've got to be careful what we say. But if there's any guys out there that are thinking of becoming entrepreneurs and setting up a business, get yourself a sensible female business partner. Because you just heard the sensible part of 3DMD, now you're going to hear the crazy bit. This particular slide, actually all the pictures on the left-hand side of this slide came from a keynote I did in Moscow in December 2000. Yeah, Moscow was a cool place to hang once. It's not quite certain at the moment. And that presentation was actually called Populating the Ghost Town of Cyberspace, because that's what we called it in those days. And at the time, I believe we were probably, and somebody's going to disagree with me, the first company in the world to launch a commercial Metaverse service. In fact, one of the sites was just a mile down the road over there in Stevens Creek. We had a booth in a GameStop store. You could go in. It would be a true medical 3D scan. It would convert you into a Quake 3 clone. It was called the Clonerator, Deliverator. I don't know whether that was psychologically there, but what was brilliant is 32 days before the world fell apart, we had a double-page spread in the New York Times discussing it. And that was actually filmed at the World Cyber Athlete League. Those of you remember that, Angel Muntz's group. And in fact, John Carmack was the only publisher to open up games so we could do that. So there's me standing at the World Quake Championships. And in fact, Fatality actually played a demo game immediately after winning the championship. So we've been thinking about this for some time, but I'm really glad that it didn't happen then, because it has been patently clear over the last 20 years while we focused on the medical side that the world was not ready for the metaverse. And nowadays, we're using Web 3.0 because we've got to remember that's what it really is. But I love the metaverse term. I think it's great, it's cool, it describes things, but it'll probably be something else next year this time. But there's a whole series of aspects on how we can use that information in and what we've learned on the healthcare side. So the first thing we've got to do is teach the web about people. It still knows nothing about us as individuals, what our movements are, what our mannerisms are. You still can't buy clothing right first time on the web. 22 years after boo.com, please, why can't we do this? That's because we've never trained computers about people. And that's one of our roots, the computer vision world. It's the fastest growing academic conference I go to. In fact, it's in a couple of weeks' time in New Orleans. That is the group that's looking at human perception and how you translate those to computers. But at the same time, we need to train these devices to communicate with people. They need to be in line with actual performance of people and so on. Some examples here. I mean, this is a guy doing an everyday activity. So I hate this, he's pulling his phone out of his pocket. That's the point I always drop it, actually. But not only we've got an avatar of him doing it, which is actually ground truth, but we've superimposed a very basic skeleton in there, so we're looking at animation on it. And you can see we're pulling out core dimensions. We're looking, I've kept it very simple on this one, the superimposition on this, but we're looking at a very simple thing like the width of his forearm and so on, and say, what's actually happening to that body as he does this? This is valuable information en masse going into an AI system to start looking at human behavior. Here's another one. No one still can agree what a waist measurement is. How long did we first define waists? Most of the tailor's measurements are Victorian. They came from London in the tailoring era of the empire. But what we've got is the ability is once we've produced this ground truth image of him, it doesn't really matter what that waist is. We can choose different variations on it. We can look at that, and we can quantify that going through. So these are sort of very simple ways in which we can teach computers about people. Hands, hands was the biggest topic in 2020 with everything going on. You couldn't scan people anymore because we had a few issues with social distancing. But we began to get very interesting how we can use hand gestures to communicate. So these are probably from what is the best hand model out there. They're static views in a dynamic sequence that are used to calibrate the Mano model, which was developed by the Max Planck group in Tübingen, one of the great centers of computer perception. Here we've modified it further. So there's some dynamic Mano models at the top of there, but down here we're doing complex things with it. So the mouse change is actually happening on top of a transparent table. It's actually for a system designed for teaching robotics on very complex hand movements. And as you can see, that's a pretty intricate interrelationship between the hand and an object. And, a lot of these images about what we don't expect to see. This is a young lady we've been doing longitudinal studies through her college development. She's a cheerleader. She got a scholarship for cheerleading at university. This is qualitative, not quantitative. But look at the movement in those thigh muscles. It's all kind of strange on this one. So there's an expression in Alabama, you don't know what you don't know. And that's the thing that you find when you do these kind of images. You suddenly see soft tissue flying around all over the place. This sequence lasted barely half a second, and we've slowed it right down. It was sampled at 60 hertz. So in many respects, we've got this. But as I mentioned, a lot of the other things we're doing is actually training devices in line. So our systems are very open. They enable you to produce common calibration systems across some object that you might be training. It's kind of very rare. I think I may have seen a presentation today that saw a device we've helped with wearability and change. Most of the devices we work with the customers we have, we simply don't know what they are. So we've defined a whole level on there that you can link into it, share calibration models, share synchronization, so you can actually run that device in line with the human movements. Then we move on to wearing it. That's the kind of level we want to get down to. Some people have spotted there's some really good real estate behind the ear. It's probably quite a comfortable way to stick things, a computer, a battery, all sorts of things could go there. To try and get that to 100 microns across that variation. I had never realized how complex that area is. I mean, some people have great big caves there. Other people have bulges. It's incredible to do that, and actually the product testing on that one was quite interesting. And here we have, this is one of our employees brought their headset in, so I don't want to imply any support of any particular headset, but we look at his facial movements before and afterwards. We've heard a lot of the presentations talking about strain, wear, the red marks we get on the face. These are important issues if we're going to be wearing devices all the time, whatever they might be. We are going to be wearing that metaverse in this respect. So I'll pull some military examples because, it's great to contrast what we were talking about in Kelly's presentation about rebuilding these poor people when they come back, as opposed to what can we do to prevent the injuries in the first place. Here's a good example. It's sort of relevant to this, but it's a stylized one. He has a real problem with the strap on his helmet when he puts his night vision goggles on, which we can't show for other reasons of classification here. So we look at what the effects of that tight strap versus that loose strap. Okay, so not necessarily a headset, but the same kind of related areas. And we superimpose those facial movements on top. That's the degree of accuracy and dynamics we can get down to with this kind of technology. Here he is, same with backpacks. That's quite a controversial one. They got to wear them for a long time. Again, we're probably going to be wearing things that I don't think will be bulky like backpacks, but we're going to be wearing, again, things around our body. Maybe in our clothing and so on. We want to make sure that's comfortable and so on. So again, we can look at how much that slows it down. We actually did a project a while back for one of the special services groups, and they had an issue because they had a garment that they had full mobility in, but it reduced their confidence. And if you're in special forces, you don't want to get out there and lose your confidence. And this thing was too tight. It was causing those sort of issues. So design is going to be important on this. This one's interesting. We look at clothing and drape and how that fits on. Now, it's an interesting thing. She leaks all over the place. She was our receptionist at the time. You noticed something about the drape of the cloth around the midriff. She's quite happy for us to say this. She was actually 3 months pregnant at the time. There's a lot of information on human perception in there. The way she's holding her hands around the midriff, you see the flow of that material on there. There is a vast amount of information to be harvested about people. Here's some of the people that have actually been doing work on this one. These are typical publications on this one. So we got to get people in there. So guess what? All these images you had a texture for free. So here we've upped the quality of the cameras in there. We've put some UV maps on. We've changed lighting. Any one image can actually have two completely different texture maps on it if you want to. We've done ones where we've actually put heat sensors on, and we look at thermal efficiency on it. It's more of a healthcare one. But as you can see there, that same enrollment, that same person going in the system, on one sense at the back, we've got all that information, design of the ear. The front, we've got a candidate avatar. And there's kind of detail inside. And it's all happening in that single one enrollment. So enrollment, I love the Science Museum. I showed that one at the beginning. We actually produced the world's largest ever avatar farm there back in the early part of the 2000s. About 350,000 people actually went through and created an avatar and went into a little mini metaverse where they could morph themselves into an orange or a piece of wood. But we've done a few studies there. Here's one we did with UCL, with Imperial College in London. And this involved people coming in their street clothes. It just closed down in January 2020 before they were there. But each person spent 30 seconds in there. I think we ran them at 30 hertz. So we got a vast number of frames there. During that period of time, they could do standard movements, and then they had 15 seconds to improvise. They were wearing street clothing. Really useful if we're looking at applications where we want to spot people in the street and what they're going to do. And here's just an example of expression coming through. So as you see, in this one, we got a candidate avatar information from, but we've actually got a lot of human perception things in there. Plus, we've got some movement, because that head's nicely in there. So in that one enrollment, we've got all three things covered. So what about avatars? Woo, they were dissed this morning, weren't they, in the keynote presentation? So avatars may be useful for size and fit, try-on clothing. I really would want to disagree with the role of the avatar in the future. Now, our marketing department is obsessed with hexagons at the moment, so you've really got to come up with 6 things here. But let's go back to the original avatar. It's a Sanskrit word. The god Vishnu represents an avatar. It's there. Those of you who are fans of Ancient Aliens will know all the legends around how avatars were 4,000 years ago. But we look in this one, and let me give you 2 examples of what avatars really mean. And these are real live pilots that were multi-million-dollar pilots. One was Under Armour. They built a warehouse in 2016 in Baltimore. You could walk in there, be scanned dynamically. Your scan could go into a virtual fit for athletic clothing. You then go into a CAD diagram, go off to automatic machines, print your apparel, and you walk out with it 2 minutes later. It actually worked. Problem was supply chain and how these damn machines connected together. It was pretty primitive on those things. But it was a multi-million-dollar pilot. It worked. There's some incredible videos. In fact, the launch sportsman was Torrey Smith just before he joined the 49ers across the street. And he was absolutely amazed. He'd never seen us 30 seconds capturing jumping jacks and to see how his clothing could be made. The ultimate avatar that I've seen so far is actually the Human Longevity Project. They had a pilot project. I think it was costing in the region publicly, it was said to be $50,000 to $80,000. Celebrities, people of high wealth would fly into San Diego. They would have DNA analysis. They'd have CT scans, MRI scans, anything that could be thought. And their health was presented in a single avatar of them. They had the choice of whether they wore sweatpants or the largest organ in the body was visible, which is the skin. So the concept of what could be contained in an avatar is absolutely phenomenal. So we've got to think of them more than just a flimsy presentation. Now, the point is, it's up to you what that avatar is. It's a multi-personality. Once you put yourself in there, you may choose never to look like you, but you still might want to have your mannerisms in areas like this. So it's very important. Guardian Angel, that thing in London, wouldn't it be great? I would willingly give my avatar to the Metaverse if it would protect me walking down the street from driverless cars, because that's what worries me about them. We're pretty good at spotting drunken people walking off the side. Not that I'm ever drunken on the sidewalk. But if I teach the Metaverse about mannerisms, maybe there's a hope in hell of not getting mown down by a Tesla. So the last thing, and here's the bummer, and this is what I would like to have really talked about today, but I'm just going to raise it here. If we allow the chaos of Web 2.0 on the Metaverse, we are screwed. Come on, there's no control over personal data. How on earth could this happen? How do we have no control? If an image goes on the web, what, it's there for eternity? I'm not quite sure, but backups aren't that good, are they? But the point is, we've got to do something about creating security into metaverses from the beginning. And if we don't, it ain't going to work. And somebody's got to take responsibility for it. There's only so much we can do, but we have a strategy now that all data will be encrypted from the moment the person goes in that system. How that becomes unencrypted, how it becomes derived and used. I've put some standards up here because these are personal favorites. They're all ones that we're directly involved in. They're all groups that actually asked us to get involved with them. I'm a board member of the Web3D Consortium. It's good old-fashioned good technology. So we've got to have things like NFT-style licensing. I need to be able to withdraw that avatar or that version of me from the metaverse at the moment I want to, and it's no longer usable in those apps. And if we don't do things like that, we got a big problem building up here because the data that you're putting in there has got your genetic information. My DNA is in my face. It's proven. There's medical papers that show it. We want to be in there, but we need to use it responsibly. Thanks very much for your time. Any questions? There's 2 microphones here for those that haven't spotted them yet.
Thank you very much for the presentation. I'm curious, you showed the ability to capture gestures, and that's something that's really valuable for people who use sign language, because it's very hard right now to capture signing properly in XR.
Yeah.
Do you see a world in which the type of equipment that you use for this level of stuff is available to individual consumers?
Yeah, I think without any question. I mean, from our point of view, we're obsessed with creating the data in the first place. What devices might capture people in the field and use is not something that interests me. What I'm interested in is enrolling 3.5 billion people, which is the market for the metaverse. It's the old cellular market. So I think that's the important thing. And I don't know yet whether everybody will need this degree of enrollment to use them well, or whether they'll be able to be enrolled from their cell phones or some other more simplistic avatar device. I really don't know, and I absolutely don't care at the moment, because until we create the ability to use that content, there's not much point in going forward. So the projects we're obsessed with across many technology companies, which we can't talk about, people are realizing they've got to learn about people. The sign language one I particularly like. I used to have a picture on the hand slide, because everybody that's sticking these things in our ears that are making us deaf, we're all going to be talking to each other sign language in the future. So it may actually be important in this context.
Thank you, sir.
All right, can we get a round of applause for Kelly and Christopher?